Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on January 6, 2026, about 6 days ago. It reports a striking achievement, where a simple setup generated 130,000 lines of formalized topology in just 2 weeks, for a total cost of around $100. The paper is titled 130K Lines of Formal Topology in 2 Weeks, Simple and Cheap Autoformalization for Everyone? And as we'll see later, this low-cost approach suggests that large-scale formalization might soon be accessible to everyone. Well, even though the project cost roughly $100 in subscription fees, Table 2 highlights a massive discrepancy in reported value. Here, the author logs the API's internal cost reports hourly over a 3-day period. In the first 4 columns, you can see the cumulative value climbing steadily, reaching amounts that would be prohibitively expensive on a standard plan. Then, in the 5th column covering hours 49 to 60, the cost hits a hard ceiling at roughly $2,500 before suddenly resetting to a lower value, which illustrates the quirky behavior of these usage limits. So, having seen the cost breakdown, Table 1 tracks the resulting productivity in terms of formalized lines. It displays the commit number against the total line count, arranged across 4 sections. In the first column, you can see the project starts slowly, accumulating only about 5,000 lines by commit 900. However, the pace accelerates significantly in the later columns. By the final column on the right, the total surges to nearly 150,000 lines, a leap that corresponds to the author switching to the faster ChatGPT Pro subscription. Alright, while the previous table showed the aggregate volume, Table 3 breaks down the specific mathematical victories. It lists the major topology theorems proven, ranked by the sheer length of their formal proofs. The standout entry at the top is the second step of the Topology extension theorem, which alone spans over 10,000 lines and relies on 142 dependencies. Just below it, you see classics like Urysohn's lemma, which also demanded thousands of lines. Well, while the previous table ranked theorems by sheer size, Table 4 provides a qualitative assessment of the formalization accuracy. Here, the model evaluates specific results like the pasting lemma, found near the top, describing it as an excellent stress test with well-scoped hypotheses. Moving down the list, you can see assessments for core concepts such as the tube lemma and the Heine-Borel theorem. The rightmost column consistently notes faithful encodings and clean abstractions, suggesting the auto-formalized proofs are not only compiling, but also mathematically sound. So, continuing down the list in this table, we reach the assessments for the most complex theorems mentioned earlier. The top rows focus on the Urysohn lemma and the Urysohn metrization theorem, where the evaluation is glowing, describing the work as excellent, and noting that non-trivial constructions were handled well. Just below that, the entry for the Topology extension theorem confirms it as a very strong result with sound dependencies. Moving to the bottom section, which covers advanced topics like the Michael lemma and the shrinking lemma, the assessment verifies that the model successfully managed technically demanding concepts like locally finite covers. Wrapping up, this paper demonstrates that massive formalization is now accessible to everyone. By pairing a large language model with a proof checker, the author generated over 130,000 lines of code for just $100. It suggests a future where digitizing math textbooks is cheap and routine. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.